So this tells us some things. This tells us that this is 80 newtons, and this tells us that this is 60 newtons. Um, and now, if I want to, I can draw a free body diagram or analyze the free body, or I don't have I have the free body diagram. I can now do Newton's laws. I can now do like we've been doing before. I can do, what's going on in the x direction. Now I have to remember that the x direction is, now acting along this way, and the y direction is now acting along this way. But that's fine. If it gets bothersome, just kind of, if it gets bothersome, nope, that's not what I want. If it gets bothersome, you just got to pretend to tilt it. Right? Um, and so if I look at the diagram, the only x force I actually have is FGX. And that's going to be equal to MA because, oopsie, I should have started out with the statement that summation of the forces in the x equals MA. I know this is going to slide down the ramp, and I made x direction down the ramp. And so I already did the work above, that 60 is going to equal mass times acceleration. And you're like, well, we didn't give mass. Well, we actually did get mass. Off to the side, we can realize I did tell us, Fg equals mg. I did tell us that the gravitation was 100, so m, and I know this is 9.81. So I do know the mass. The mass is 100 divided by 9.81, which equals, I should get this on my calculator. 10.2 kilograms. And so 60 equals 10.2 acceleration. Acceleration is going to equal 5.88. Now it'll be down the ramp, which we call positive. So it'll be positive. So that's fine. Now, what we didn't use, and we didn't need to use, but I'm going to go over anyway, is the y direction, because if we were to have friction, we would need the y direction. Why is that? Well, in the y direction, because we have the axes tilted, we are actually not moving in the y direction, right? Like, if we have our box, that's a terrible box. If we have our box, we're sliding down the ramp. We're sliding in the x direction. We're not rising up. We're not going down into the ramp. We're sliding along the ramp, all pure x. There is no motion. Again, with these rotated axes, there is no motion in the y direction at all. You put it at the top of the ramp, let it go, whee, slides on down. And so we can assume that our y direction is in equilibrium, but that means that the normal force minus not Fg anymore, because it's not all of gravity. The only portion of gravity that acts in the y direction is, well, the y component. And so that means the normal force is less than the gravitation overall, which we discussed earlier in case 1 through case 3, right? And so that, what am I doing? Sorry about that. Tapper, you're a mess. So now the normal force is going to be equal to the 80 newtons. Now this doesn't make any difference in this particular problem, but what if there were friction? Because remember, friction is equal to mu times Fn. So when you have something on a ramp, this is going to be important, because that friction is going to be affected by the angle of that ramp, right? Like if I go back up here, if there were friction, you know, in this particular case, we said normal force is maximized. So that means if there were friction, normal force is maximized. So if the normal force is maximized, that means friction is going to be maximized. In case 3, if we're, sliding along the table, but there's no real normal force to speak of, even if there is a mu, even if there was a mu, but there's no real contact here, that means the friction is also not really going to do anything, right? Because again, force of friction is going to be related to mu times Fn. Well, if normal force is almost 0, then friction is going to be almost 0. But in this case, case 2, if we have a mu, well, we do have normal force, but it's not as strong as case 1, so our friction is overall going to get smaller. So the higher the angle and the less normal force happens, the less friction you're going to have. And I hope that makes sense. So I'm going to stop here. We have a couple more. I'll do at least one more example where we solve for a situation where we have some friction and some other things. Okay.